open slots. So if anybody has been doing any programming or developer related stuff at work or as a hobby, we would love to hear from that. The Tech Weeklies calendar, you can find the link in the email and Slack. If you want to give a talk about something, just book a slot there. If you want to kind of get some help with that, want to spur some ideas, feel free to send me a message as well. More than happy to help. But to today's topic, Jan is going to talk about property-based testing. And I'm going to give the stage to Jan.
Cool, thank you. Hi, everyone. I will split this talk in two. So first I will explain with a presentation, like what do I want to do and what is the point. And later I will show you how this actually looks in code and what is the benefits. So property-based testing basically means you don't write unit tests like you normally do, where you have a fixed set of examples and then you assert like 5 plus 10 is 15 or something like that. But you let the testing framework generate random inputs for your tests, and then you need to find a property, like something that always holds depending on the inputs for all possible inputs that you can get with the random generation. So for example, one property you could test for an addition function is, because you can't just test if the addition function returns a plus b, because then you would just re-implement the addition function without testing anything. So yeah, you want to test properties that represent the assumptions you make, or the invariance, as said in the chat. So for example, for the addition, you could test that a plus b is the same as b plus a, which just comes from how the addition function works. And there are other properties you could use, and one of them I want to show you and later talk about the second one. So what did I want to test? So I'm one of the core team of Cycle.js, and Cycle.js is a framework that is based around streams. So if you use RxJS, those kind of streams. A stream is basically like a promise, just that a promise only emits once and then it's finished. A stream can emit multiple times, but also can finish. So there's two signals that come. There's like the data and the finish, which is separate. And a stream is multiple data and at most one finish. If you don't have a finish, you have a stream that just goes on forever. So the function what I want to test or wanted to test is the combine function. It basically takes a set of streams and then I have it here. So you have a bunch of streams with some data on them. I just marked them here as little dots, and then combine weights until all of them have emitted. So first stream 2, for example, because it doesn't matter in which order they emit. They can emit at any point in time. So then nothing happens. Stream 3, nothing happens. Then this can emit again and still nothing will happen. Only when the first time all of the streams have emitted at least one value, then like the current set of values will be emitted as an array. So this is, for example, in Cycle.js, this is basically how you compose different parts of the DOM. You wait until all the child components have at least once emitted their DOM, and then you can put them together and make one new DOM out of them. So combine is pretty central. So I wanted to test it. So another example, now if there's another emission, it will take the last values plus that new value and emit a new array. Same for this. So as you can see, like the order of emission does not matter. For every, once all the slots are filled here, once every stream has emitted at least once, then every emission from any stream that comes in will result in a new emission on the combined stream. This is just how this thing works. So that's what we want to test. The issues is now, these streams are asynchronous. So they can emit at any time, and there's nothing we can do to check if this, there's no fixed order in which they emit. And also a stream may emit multiple times before combine emits anything. So we have to keep that in mind when designing a test. So here's summarize what we want. We have an arbitrary number of streams. We have an arbitrary set of data per stream. So here I have every stream had the same data, but that's not the usual case. And everything is asynchronous And thus we have an arbitrary order of execution. So any stream may emit at any time. But the nice thing is, because we are here in JavaScript or TypeScript, doesn't matter, it's a single-threaded language, so it cannot happen that two streams emit at the same time. Because JavaScript is a single-threaded language, everything happens one after another. So we know that only one can emit at any time, which is at least something we know. So has anyone an idea how you could start to tackle this problem? And I can also give a hint. Think about what does stay the same, even with all those arbitraries in there. There's few things that stay the same, and this is the core of property-based testing. Like you think of no matter what stays the same. Okay, I will show it. What stays the same is the order in each stream. So if we look at the beginning, stream 3 had like blue, green, and red. And in the end, after emission, like blue was not here in emission, but red was not before green. Like green always has to come before red. Red may come multiple times because another stream emits in that same time, but like the ordering inside one of those columns always has to stay the same. So let's use that property for testing. First, we let the framework generate us our data, our test data. So in this case, we have a two-dimensional array that may be of any length with data. I've like for demonstration purposes, I showed it like this. So each of those are then transformed to a stream, which is pretty easy. And then again, we don't know the order of execution, but after combine, we know at least that, for example, here, green has to come before red, and same here. This is not totally accurate because for my test, I will show you later, I'm actually disallowing duplicates in the stream to make the assertion easier, but in theory, it would not matter. Again, as I said, like green always has to come before red, but it might, like the number of times it comes here is not defined. It can be 0 if this stream emits twice before any other stream emits, or it can be like here multiple times when other streams emit in the meantime. But this thing, like the order inside a stream, does never change. So I think that's also like, yeah, the last of my explanation slides. So now I will show you how this actually looks in code. I think this is now readable for everyone. First, this FC you see here, this is fastcheck, which is a TypeScript library for property-based testing. There are libraries for this for basically any language. One of the original implementation is QuickCheck for Haskell, but nowadays there's multiple libraries for any language. So there are also JS Verify, I know, but it's only JavaScript. And I recently discovered fastcheck, which is written in TypeScript and has also nice types. So if we go back to that test, first we prepare ourselves a abbreviation. Because as you saw in the presentation, we need an arrays of data. We need to filter out, to make our lives later a bit easier, we need to filter the data that could be generated. So first we say, okay, we want to generate an array that contains anything. So anything is in shorthand for numbers, strings, objects of variant depth, null, undefined, so anything a program could throw at you. And then we need to filter that we don't have not a number. The reason for this is because later we want to check here, like if we want to compare those, and not a number is not equal to not a number. So this would throw our assertion out. So we could not really assert otherwise. So we filter out not a numbers here. And we say, okay, this array, please make it between the size 1 and 10. And again, because to make assertions easier, we require that this array contains no duplicate values. So this filter will say, okay, create a new set, and a set eliminates duplicates. And then if the set is the same size as the array, we know we don't have duplicates. So this is basically how to generate one of the data arrays here, like one of the columns. This is the actual test. So you see here, we have this fastcheck.assert, which is used to assert on a property. And because we're testing async code, we're using this async property function. We give it as argument. We want to generate an array of our arbitrary here between 2 and 6, because those are the interesting values. When it does something interesting. And we get this array here. And if we look now with hover, we can actually see it's a 2-dimensional array, but because it uses anything here, the type is unknown of that array. So it is a 2-dimensional array of unknowns because it could be anything. So that's what we want here. This part here is just to make the streams emit asynchronously. You see here, I'm using set interval with 10 milliseconds for every of the input arrays, which means because like they are fired basically at the same time, and set interval does not guarantee anything about ordering. So if you have, for example, even though in the code you write, those 2 lines are after another with the same timeout, they could, like those loggings could be in any order. That's just how set timeout works. And the same is also true for set interval. So this is how I make the ordering arbitrary, because that's what I want to test, like with arbitrary ordering, not only with fixed ordering. So going back here, this is the part where we actually, like, this is the system under test. And because we are using this async property, we have to return a promise. This could also be an async function, but I'm not really a fan of async await, so I'm just using plain promises. The code that we test is pretty simple. We pipe, like, this is the function we want to test, and then we just collect all the emissions. So we collect all of those. And then once we are finished, so this is the end signal, as I told you earlier, then we give this complete list of rows we collected. So here, every row we found until so far, and give it to this part, which is then the actual assertions. And you see here, I'm first preparing a variable for the columns, and then for each of the rows, I'm first asserting that every row has the length is as long as we have streams. So for example, here, if I have like 4 streams, I would assert that combine, every row of combine has 4 length. This is pretty easy, but it doesn't hurt to have it there. And then I'm basically just for every item in the row, I'm putting it into this column store and push it. So basically I'm converting from an array of rows to an array of columns, because then I can basically get back to the data I get started with, because that was also an array of columns. And when I collect the rows, I get an array of rows. So I'm basically just transforming how I store the data. And then if I have like all the columns collected, I can, this is the important part. I'm only adding it to the column if it is different from the last item. So this is how here, for example, this will get added because there's nothing in the column yet. This will not get added because it's not different from the one before. This will also not get added because it's also not different from the one before, but this will get added because now this one is different. That's also how this test could be improved. At the moment, I'm disallowing any duplicate here, but for this to work, I would also only need to have like 2 neighboring items to not be duplicates. So this would allow to have arrays with, so this could be improved here. This just for simplicity's sake. So just that this strategy of squashing down the duplicates works. And if we then go down here, so then we just check, is this column array equal to our input data? If we transform the rows to columns, remove the duplicates, is then this column equal to the column we put in? So this is how we close the circle and actually assert that our implementation does the right thing compared to the input. If we run the thing now, let's make this also a huge chunk bigger. Yeah, now the framework will generate, I think I have configured it to be 100 tests. So it will generate 100 different inputs and check if the property holds for all of those inputs. This is also what makes property testing nice for CI, because you just can increase the threshold. Like you can say, okay, generate 1,000 test cases if you want, which is quite nice. And the test passes. And because we are generating quite a few tests, and each test takes like 100 milliseconds or so because of how I emit the stuff, it takes some time. I wanted to show what is a complicated way to test with properties, where you think about like linearity or ordering of stuff. But there is also a lot of more very simpler ways to do this. And I also want to show that one to you. So if we go here, you maybe saw earlier in the first test run, we have this array oracle test suite here. And this is basically using an oracle. What does oracle mean? We want to test our implementation. And using an oracle now, we have some known good implementation. In this case, we are testing against the array methods that are implemented in the browser. So we assume like the browser is heavily tested. We assume that array.map, for example, does the right thing. So if we like use our map implementation on streams and check if the data with array.map is the same in the end, then okay, we know that our implementation does the same thing, and which is the right thing. This is also very useful for refactoring. So you can write a test, a property-based test that takes your old known good, or what you define as known good, and your new implementation, and tests if the new implementation does the same thing as the old one. Either they behave the same, which is nice, or they behave not the same, and then you can decide if this is a bug in the old version or this is a bug in the new version. So then, because the nice thing about property-based testing, which I will also give you now, I need to quickly go here and run the tests again. Because why am I telling you this? We recently had a bug in this very combine function. Even though I already had used property-based tests. The reason for this is that this is not foolproof. You see now I get tests that fail. If I show you the head commit, the interesting part is here. So I'm converting from integers to anything. I was just testing on numbers here. When the functions accept any input, which is obviously not the correct thing to do. And like those two were not a problem, but if we go later, yeah, here. Sample combine uses combine, or combine is defined in terms of sample combine. This was the test that was not failing because we used integers, but was failing for anything. Why? Because combine was defined like this. We have, this is the array, and I go back, wait, if we go here, I showed you earlier, combine has this internal state and only emits once all of the have emitted. Here, we define this one to be an array that we fill with undefined. And then later on, we check, does it still contain undefined? If it does contain undefined, we have not all of the streams have emitted. So we wait. If all of the streams, if none of them are undefined anymore, then we emit the array. So just like here. So here we have two undefineds, like here is undefined and there is undefined. And once everyone has emitted, there's no undefined here, and we put out an array. Can anyone spot the bug in this one?
Is it because the anything returns undefined as well?
Yeah, because a stream could send undefined as well. So then the stream sends data, and undefined is a perfectly valid thing to send. But how we implemented this was then not emitting, which is wrong. So that was the bug we had. And this was not found by the tests because I used the wrong data for the test. Like if I only test for numbers, I only know it will work for numbers. So it's not a silver bullet. So, but going back to the source, to the Oracle tests, One thing that is nice, for example, let's take a rather simple one. So here you see map, which is, I have wrote a small helper function. So this is here the map test. So we generate an array of some input data, and we take a function. And then with the array and the function, we basically, our oracle here is calling array.map in our case with our function. And here we do the same. We convert the array to a stream, run our map function in this case, push all the data into an array, and then in the end, we assert that there was no error, and we assert that our collected array is the same as our oracle, and then we just assert that this code actually ran. So this is a much nicer thing to use if you have to, like, the thing is, you can't always use it. If you have a known good implementation or a model, like this is also sometimes known as model checking. So if you have some model, a state machine, whatever, that implements like the known good that you are sure is correct, then you can use a very easy property to test against this model or known good implementation. Another thing, as said earlier, are stuff like mathematical laws, associativity. If you have like a function that where the parentheses should not matter, you can test this. Distributivity, but it's not always easy to see how to incorporate those in real world tasks. Another nice thing to use is if you have something that is reversible. So for example, encoding and decoding. If you parse from JSON, for example, and then write back to JSON, not sure if you do this in your applications, then you can just check if writing to a string and then parsing back returns the same data structure. Usually the other way around is not valid because usually a parser does not care about white space. So just say that if you parse and print back again, that should be the same, is usually not valid because usually the pretty printing does not know which white space was in the input. But the other way around, first writing and then parsing again usually works. So these are like the small, like the tools on your tool belt you can use to test without having to write many tests, which is the core of what I want to bring. So testing, like writing unit tests, it creates more code. It creates a more code surface area, and it's also not easily seeable. Like if you have just one example, it's not easy to see what is the assumption. Here it's easy to see that the assumption is that my system under test behaves the same as array.map in this case. So because I called it here with array.map. So the assumptions or the invariants of your data structure or your code, at least in my opinions, are clearer with a property-based test, because those assumptions are the only thing you have to test. There is no static, like I'm not a big fan of those golden tests, or like where you have let the test write out a file that you commit and then you check if the file did not change, because it's hard to see what is actually happening or what is the assumption. Like for a newcomer, it's hard to see like what should the thing do. It should not change the file, but sometimes you might want to change, like the output might change, but what is the thing that should not change? Like the assumptions are usually deeper than just like nothing should change. And so I really like property-based testing. I try to incorporate it more often. But on the other hand, of course, it's not the easiest thing to do. Questions, please ask anything.
I think there was a question by Olavi in the chat.
Why Tenet wouldn't want to do this? Yeah, it probably would. That's just me defaulting to 10. Yeah, I said this chat can be made better. So if I go back again, as said, for example, that timeout doesn't need to be 10. 1 or 2 would totally work. This filtering is a bit too restrictive. I don't care if I have no duplicates. I just don't want duplicates that follow each other. So consecutive duplicates, that I don't want. So this still does not test all the possible inputs, but it's already a lot better than, for example, just having a test that says, okay, for this particular example it works, because I would not have put undefined in that test case just by myself. That's not something I usually think about. And I once read, for example, in an article about TDD, that you should think about the edge cases. But then, I mean, if you think about the edge cases, you probably don't, like, you implement them correctly. It's the edge cases you don't think about that are the hard ones. And in this case, that was exactly an edge case I did not think about. For those are interested, the fix was pretty simple. We just use an empty object as a marker. So we fill it not with undefined, but with the empty object. And because if we create two empty objects, those two are not equal. Because it's a new object. It's newly created, so it's not the same, even though it's structurally the same. So no matter, even if the user now sends an empty object, down here it will never, okay, it was optimized a bit, but it will never find another object that is equal to that one. You could also do the same one with a symbol. So if I just do here new symbol, but this is just symbol, I think it is. But this is overkill for this use case, because this empty object works exactly like a symbol in this case, and we don't need to force users to have a symbol in their browser. So it works also on other browsers. This was a neat little trick I discovered, which is, just wanted to show you. If you're interested in this project, it's callbacks, which is basically, for those that are interested, it's I can show you the implementation, for example, for from array that I used earlier. So it's a function that takes an array that returns a function that takes, this is again a function. So it's this is called CPS, or continuation passing style, which the user of the library does not have to care about. It's just the internals. For those that are interested in this, it's a very efficient encoding for streams, and I can share, like, it's not actually a library. Well, there is a library, but the library follows just this standard. This is my co-maintainer of Cycle.js, by the way. He used to work at Futurice, so some of you might know him. So this README is basically the whole magic behind this, how it works. It's not long, but it's quite hard to get into. There's a good blog post about this, and if you want, you can also take a look at the implementation that I did. Cycle.js callbacks, this is called. So this is the code base I just showed you. So there in the test folder, there are the property-based tests, and in the source folder, there is this same code I just showed you. Yeah, this is basically how to implement RxJS without having to write, with only relying on functions. So you don't need any core type or anything. It's just functions that get passed around, which makes this is very small. Like the whole library is just, I think, 3 or 4 kilobytes minimified, versus RxJS, which just the core, which lets you do nothing without any operators, is already bigger. Yeah, but that's just as an aside. It's not relevant to the topic of testing. So if you have any questions about any of this, feel free. Otherwise, I said enough.
All right. Thanks a lot, Jan, for the great talk. This is the only talk for today. But before everybody leaves, next month is Hacktoberfest, which, if you're not familiar with it, it's like a month dedicated for open source. And we are planning to organize some fun stuff related to that. So if somebody wants to be involved, whether you have some ideas or you're a maintainer of an open source project that you want to promote, join us in Slack on channel Hacktoberfest-organizers. I will share the link also in the Dev General Slack channel in the thread. Other than that, have a fantastic weekend, everybody. If somebody wants to give a talk, you know where to find the calendar. Yes, we have one share something that you've been working on. Super. Have a nice weekend.